Well, welcome to class again, and we will go ahead and wrap up chapter 1 of geometry here, learning about polygons and how to classify them. So let's get started. A lot of this you probably know already, but so if you know it already, this will be a review. So our objective, students will be able to classify polygons, and so naturally we want to know, how do you classify them? You can think of it like this way. It's often a situation where you have to classify them according to some sort of characteristic, like animals and stuff like that, whether they have fur or whether they lay eggs and stuff like that. We classify certain animals. Well, the same thing is true in mathematics. We have certain figures that have certain characteristics, and we'll be classifying them according to their characteristics. So let's find out what those are. So the first thing we want to know is just, what is a polygon? Well, the word poly here means many, and so basically a polygon means many sides, although many sides could be as few as 3 sides, and it can have as many sides as you want, maybe 100,000 maybe even, but normally we deal with smaller number of sides for polygons. 3 sides, 4 sides, clear up to 10, maybe 12, but usually that usually covers the most common ones. So we'll deal with those. Well, what is a polygon? First of all, it's a plane figure, which means it's flat. It's a two-dimensional picture, and so we're not dealing with any 3D shapes. So polygon is just a plane figure, two-dimensional shape. Let me just draw one real quick. Here's a, well, first of all, you may have seen, like, well, here's one right here. Imagine all these segments are straight. What I've drawn right here is a 5-sided polygon. It's a plane figure and it's closed. Okay, so it's closed. So what that means is there can't be any opening. So this here, for example, almost looks like a square, but if it stops right there, there's like this opening right here that you could kind of come in. Polygons don't have any openings like this, so it's a closed plane figure with the following properties. Let's find out what properties those are. We have 2 of them. First of all, it's formed by 3 or more line segments. So remember, line segments are straight. Okay, so line segments are straight. They come from lines, and so the sides of a polygon must be always straight, something like that. Well, that's ugly. I shouldn't draw up there. Maybe I should draw an example up here somewhere. You know, it needs to be straight. Each of the sides need to be straight. So that's one requirement. The second requirement, each side intersects exactly 2 sides, one at each endpoint, so that no 2 sides with a common endpoint are collinear. Now that's kind of a confusing idea here. So we'll have to see what that means here with some examples. So let's look at some examples here real quick. Oh, one other thing, we have certain pieces of the polygon. This one has 5 sides, so we're going to find out later on that this is called a pentagon. But each one of these are called sides, and each corner point is called a vertex. Okay, now you might wonder, well, how do we name these polygons? Well, as you might imagine, we use the letters. And when we name a polygon, we have to use all of the letters, and we can either go clockwise, like a regular clock would be going, kind of like the minute hand goes around a clock, or we can go counterclockwise, which is the opposite direction. And you can start off with whatever letter you want, and you just list all the letters in sequence. So for example, one name that we could do for this polygon is C D, E, A, and B. That's one example. And so what I did is I started right here and I went clockwise and went around that way. Okay. But you could have started at any letter and you could go counterclockwise or clockwise. So another name that we could have done, I'll just start off at B here. I could have called this thingy B, A, E, D, C. And so you might imagine there's a whole bunch of different names we could have called this thing, as long as we go clockwise or counterclockwise. So anyhow, that's how we name these things. And you just listen all the letters together, kind of like a name. And they're all capital letters because these are all points on the polygon. Okay, so let's take a look at a few more things here. And here's a good example of these two statements here. It's formed by 3 or more line segments. Okay, so notice the lines are always straight. We cannot have a polygon that does a curve like this, connecting like let's say that's A, and then this is B, and then we have something going like this, and we can't have this scenario right here because that's not a line segment. You see, line segments are straight. Okay, so you can't have this. You can't have that. Okay, so first of all, you should notice they're always straight. And another thing we can't have is something like, let's see here, a little bit smaller. Alright, so what else can't we have? Well, it says each side intersects exactly 2 sides, each at one endpoint. So what we can't have is a scenario where we have that scenario like this. Okay, even though this looks like a polygon, it's not, because of this middle segment. That causes a bit of a problem here, because if you look at this segment right here, it is supposed to have only 2 intersection points. Well, it looks like there's 2 intersection points, but well, there's one right here. Okay, there's one, because the blue segment here intersects the red one right there, so there's one. But then this blue segment comes in and intersects right there, so that counts as number 2. And then there's this third one right here, that counts as number 3. So there's actually 3 points that intersect here, and so that creates a problem here. It says each side intersects exactly 2 sides, only 2 sides only. So it would have been okay if we had that one and this one, but as soon as you add that third side, we have a problem. So can't have those scenarios either. So anyhow, that's what we mean by polygons. And let's do some other examples. Now, in geometry, we mainly deal with convex polygons, but we'll also talk about concave ones. And you want to be able to discern, well, whether it's convex or concave. Alright? And I'll give you a quick way to determine this. If you can pick any point on one segment or one side, and you can pick another point, any point you want on another segment, and if you draw a segment joining those two, and if any point of that segment lies on the outside, then we say it's concave. You see? And you can think of it like, let me just draw a rudimentary cave on a mountainside here. And like that, you know, let's just say this is a mountain. You climb up this way and you're inside a cave here. Well, as you might imagine, the cave could cave in, you know, it could cave in like this, come down like that. Well, that should help you, remind you if there's any cave-like shape here, and this is kind of an awkward looking cave right here, but if it could cave in on itself, then you can remember that it's going to be called concave. I hope that helps. And if you have this scenario on the other hand, notice wherever you join the segments or join 2 points, it will always lie on the inside. And if you join another 2 points, it's always on the inside. The segment lies on the inside. You pick any 2 points on any segment, you draw them together to make a segment, and it lies on the inside. In that case, you have a convex polygon. Pretty straightforward. Alright, let's continue then. Alright, so here's some exercises. The first thing we want to do is tell whether it's a polygon. Okay? And the second thing we want to do is tell whether it's convex or concave. Well, as we were just looking, there's 2 requirements. First of all, polygons have to have line segments. And so these are all line segments. That's fine. But do you see there's a problem right here? As we look at this segment here, it's supposed to intersect 2 other segments only. Well, let's look at them real quick. This blue line intersects this one. It comes across right there. There's the intersection point right there. There's a common point right there. And here's another one right here. This one going upward right here. That's another segment. So there's 1, there's 2, and there's a third one coming in right here. And so each segment here is supposed to intersect only 2 others, and it intersects 3. So we would say not a polygon. Well, let me spell that right. Polygon. So it's not a polygon because of that middle segment. If you took that segment out, it would be a polygon. So anyhow, here we have a simple one. You'll notice they're all line segments, and each of the segments intersects only 2 others. You know, no matter which segment you talk about. Like for example, let's talk about this segment right here. How many segments intersect? Well, there's one that intersects right here, and there's another one here. Now, in addition to intersecting 2, there's 1, there's 2, they have to intersect at the end point. Okay, so in other words, they have to intersect at a vertex. So what you can't have is a scenario going like that. Okay, because they intersect, but the intersecting point is right here now, and that's not at the end point. Does that make sense? So anyhow, this one fits the definition just fine, and so it is a polygon. So we will answer this question: is a polygon. And now we need to answer the question, this next question then, is it convex or concave? Well, there is no like cave structure, right, where it could kind of cave in on itself. So this is going to be convex. And so we're going to say it's convex. Okay. Alright, and you'll notice, like, if you pick any segment, and you pick any point on that segment, here's a point here, let's pick another point over here, any point you want. If you were to connect those 2 points and make a segment, the entire segment would lie on the inside or the interior. See? So once again, that makes it convex. Alright, well, let's move on to this third one here. This third one is almost a polygon, except for this right here. We were told that the first requirement is that it's made up of line segments. And that is not a line segment, that's a curve. In Algebra 2 we'll learn about curves. Lines are always straight though, and so that makes this one easy. This one's not a polygon. Not a polygon. And let's move on to the final one. This one is a polygon because it's made up of a bunch of segments, and you'll notice quickly that there's only 2 intersection points at the end point. So it is a polygon. Is a poly, and it's going to abbreviate. It's a polygon. And how many, let's see, is it concave or convex? Well, you notice in this case, if I were to draw a point here, or pick a point here and pick a point here, and if I were to make a segment, much of that segment is outside of the polygon. So this one is what we call concave. This one's concave. Okay? So one of the ways we classify polygons is whether they're convex or concave. Well, we can also classify them by the number of sides and whether or not the sides are congruent or not. We can also classify them by the number of angles they have, and we'll see if they're congruent or not. So we're going to move on and find other ways to classify them. And so now we'll go with the general names of polygons based on the number of sides, and most of these you already know, like 3 sides, I'm sure you know, is a triangle. 4 sides, don't say it's a square, don't say it's a rectangle. The general name for 4 sides is a quadrilateral. Let's take a look at the rest of them. Triangle for 3 sides, quadrilateral. Okay, now it turns out a square is a quadrilateral and a rectangle is a quadrilateral. Because they have 4 sides. But if it has 5 sides, it has a pentagon, hexagon, heptagon for number 7. Hepta, it's like the heptathlon. If you guys know anything about the Olympics that just happened, and in Brazil, you might recognize the heptathlon as a 7 event. You know, they do javelin, they do hurdles, and all these different events. And there's 7 altogether in the heptathlon. And likewise, heptagon has 7, in this case, sides. What about if we have more sides? Well, octagon, that's the typical picture that we see when we look at a stop sign. Octagon. Octopus has 8 arms. So the octa prefix here means 8. Nonagon. Non should remind you of 9, right? Decagon. And then finally we have dodecagon. Now, it turns out that there are many polygons besides 12-sided, like you could have 13, 15-sided and all this other stuff. For our class, we'll call these n-gons. Now here's how it works. So if you have a 13-sided polygon, then the way we'd name it, we'd call it a 13-gon. Okay? A 13-gon. So whatever number of the sides is, you put that first. In that case, this would be the 13. And then you just put a gon. And then you can call a 17-sided one, you could call it a 17-gon. Okay? I don't know where they gone, but maybe they gone crazy. Anyhow, those are the most common ones we'll deal with, and those are probably the most common that you'll deal with in everyday life as well. They come up in various situations. So there you have it. You'll be expected to memorize these, so make sure you know the first 12 at least. Excuse me, there's not 12 of them here because we start off at 3, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, you have to know at least 9 of these, okay? So make sure you know them for the test on chapter 1. What you'll have is a diagram, and you'll have to classify it. You'll have to classify the polygon based on the number of sides, you'll have to name it according to whether it's convex or concave and those kind of things as well. So, well, let's move on. There's other ways to classify things, and that has to do with equilateral, equiangular, or regular. So these words are pretty easy, and we're going to see these words come up again and again and again. So let's make sure we go over the idea. Equilateral, okay, lateral you might remember from football. What does a lateral mean? Well, it means that you passed towards the sidelines or to the side. A lateral is a sidewards. Whoops, I'll back that up. Equilateral, a lateral means side, okay? And so an equilateral means means equal, of course, and equal means equal sides. So that definition should not surprise you. If you have an equilateral polygon, all the sides are congruent. And you can probably guess what this one is. Equiangular. Okay, so this just means you have equal angles. Okay, if all the angles are equal, then you have an equiangular polygon. Now, it turns out if you have both of these scenarios, if you have both, then we have a new special name, and for whatever reason we use the word regular. Now it seems like to me they should be using the word equi again, or the prefix equi, but anyhow we call it regular. So a regular polygon is a convex polygon, and it's both equilateral, and it's equiangular. And so we'll classify polygons using these words as well. Now let's take a look at a couple of those examples. Alright, so classify the polygon by the number of sides. Alright, then tell whether a polygon is equilateral, equiangular, or regular. Okay, so alright, so first of all, we have 1, 2, 3, 4, 5, 6. We have 6 sides, so that makes this thingy a hexagon. Alright, so now equilateral means all the sides are congruent. Well, these tick marks on these sides right here, it means that all the sides are congruent. Now, if one of these had 2 tick marks instead, then we'd know that they're not all congruent. We'd know that only 5 of them are congruent, but the 6th one is not congruent. Like, that's what's going on over here. There's 2 tick marks here, and there's a single tick mark here. So this side and this side are different lengths. Oh, but anyhow, let's go back to this one. We have that all the sides are congruent. So we do have the situation where it is equilateral, but we also have all the angles are congruent, and that would mean that it's equiangular. And remember, if you have both of them, we would say it's regular. So we're going to say this is a hexagon, and we're going to say it's a regular hexagon. Alright, so there's the first one. How about this one? Now, first of all, we have 4 sides, so we say then that it's a quadrilateral because it has 4 sides. Quadrilateral. So it's a quadrilateral, but since the sides are not congruent because there's 1 tick mark here and 2 here, we know it's not equilateral. And the same is true for the angles. We know it's not equiangular because this angle has 2 tick marks and that one has 1. So this one is neither equilateral nor equiangular. So basically to describe this polygon, we'd all simply just say it's a quadrilateral. That's all we can do here. Now, what do we got here? This one is a little bit tricky. We have how many sides? We better count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It has 12 sides, so that means then that this is a dodecagon. Decagon. So I'll tell you the way I like to think of this. I think of this as 10. Okay, there's 10. And I think of this as an additional 2. I don't know why it works for me. Maybe it should be called bidecagon, because bi means 2, but in any event, that's how I like to think of it. So this is 12 sides. Now let's answer the question, is it equilateral or is it equiangular, or do we have the third option, is it regular? I'm going to erase some of this now so we can go through it. It looks like to me, based on the markings, that all the sides are congruent. They all have single text marks. So that would mean that it is equilateral. So we have this scenario. Now it almost looks like they're all right angles in here. However, the angles have to be on the interior. So those two angles are right angles, but what is this angle going around here? That is not a right angle. The exterior angle, that's an exterior angle. Exterior angle. And so what we'd say is that the exterior angle there is 90 degrees, but the interior is actually 270 degrees. And so it turns out this is not equiangular, because this angle right here is, well, let me erase this now, it's getting messy. This angle right here, it's not equal to those angles. And you'll notice we have the same problem right here. That angle, this angle right here, and this angle, those four angles are not the same as those angles. So it's not equiangular. So, and therefore it's not regular. So this one is a dodecagon and it is equilateral. So this one was a little bit tricky, if you ask me. Equilateral. So watch out for that. If it's going to be equiangular, it has to be all the interior angles. We don't look at the exterior angles right now on this lesson. Also, here's a little bit more practice here. If you'd like, you can try this on your own. I'll give you a few seconds. Alright, so the first question is whether or not it's a polygon. Well, remember, polygons are made up of straight line segments and they intersect at two endpoints only. And so it looks like to me everything's fulfilled here. Everything looks good there. By the way, how many sides does it have? It has 5, so we would say it's a pentagon. It's a pentagon. Pentagon. We weren't asked to necessarily name it by the number of sides. We were asked whether it is a polygon, so we're going to say it is. It is. Okay. Well, whether or not it's concave or convex. Okay, well, none of the segments would lie on the outside, right? If I join two endpoints on, and since all the endpoints would lie on the inside, no matter what, we would say that this is a convex polygon. Okay. Now, how about this other one over here? This one, it looks like there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It has 10 sides, and the definitions do work. There's only on each of these segments. How many segments intersect? Well, there's one. Okay, there's two, and they intersect at the endpoints only, and that's what you want for a polygon. And if you notice, if you go all the way around, the same thing happens, the same scenario. So it is a polygon. And now we want to answer whether it's concave or convex. Well, you'll notice that if I take a point on this segment and a point on this segment, and then I join those to form a new segment, part of that is on the exterior. Okay, it's on the exterior. And so what that means is this polygon is concave. Concave. And once again, concave, you can think of it as like a regular old cave on a mountainside. If it can cave in, you know, like this, it should remind you that it's concave. Okay? So I hope that helps. Let's try some other ones. Now we want to classify the polygon by the number of sides. Well, this one you should recognize. It's a triangle. Since there's three sides, a triangle. Okay, so then we need to tell whether it's equilateral, equiangular, or regular. Well, these two sides are congruent, but we're not told anything about this side. So we cannot assume that this side is equal to those two sides. So it's not equilateral. It's not equilateral. And the same is true for the angles. We only know that those two angles are congruent. We don't know what this angle is. So we can't say that it's equiangular. So all we can say for this one is that it's a triangle. It has three sides, so therefore it's a triangle. Well, let's try the next problem. How about these two? Well, this one, all the sides are congruent. All the angles are congruent. It has how many sides? 1, 2, 3, 4, 5, 6, 7, 8. It has 8 sides, so it's an octagon. And since all the sides are congruent, it would be equilateral. And since all the angles are congruent, it would be equiangular. And whenever you have both of them together, that would make the polygon regular. So this one is a regular octagon. Regular. Alright, so that's a funky picture. Let's move this down like this. How about this last one here? It has 4 sides, so that means it's a quadrilateral. Quadrilateral. And are all the sides congruent? Well, yeah, all the sides are congruent, so it's equilateral. But the angles are not congruent. Because there's only one tick mark here, or one marking for the angle, and there's 2 here, that means they're not equal. They're not equal. So because they're not equal, that means we don't have equal angularity. And so the sides are equal. So we have an equilateral, quadrilateral. So what have we learned? We've learned how to classify polygons a couple different ways. One way is whether they're convex or concave. Another way is by the number of sides they have, and also by the types of sides that they have, and also lastly by the angles. So that's basically all we're doing on this assignment. So let's try one more algebra type problem. On this particular problem, we're told that we have regular hexagon, and because it's regular, we know there's 2 facts. There's 2 facts about this regular hexagon. Fact number 1: all the sides are congruent. All sides are congruent. Okay, that's my texting, writing here, trying to save space and time. All sides are congruent. Well, we also know all the angles are congruent. All angles are congruent. Well, one consequence of having all the sides congruent, it means that all the sides are equal in their length then. And if they're equal in length, it means these two lengths must be equal. So if they're equal, I can just make an algebraic equation now. 3x plus 6 must equal 4x minus 2. And now we just use our baby algebra skills and solve for x. Okay, so I think because this 3x is smaller than this one, I'll move the 3x's over here. So I'm going to subtract 3x. Subtract 3x here. At the same time, I'm going to move the 2 over to the opposite side by adding 2. I'm going to draw my little line underneath. Not bad. 4x minus 3x is x, and 6 plus 2 is 8. Okay. Now remember, don't be a bozo. Don't stop too soon. We're asked to find the length of a side, and what we found was the length of x. So to find the length of the side, we need to take this x and substitute it right back in up to here. And so in this case, we get 3 times 8. And then we add 6 to that. And let's see, 3 times 8 is 24 plus 6. That's going to be equal to 30. So all of these sides are 30. And so on and so forth. So there's a typical algebra problem. Maybe for fun you'd like to try one. Want to give you a minute. We're told that we have an equilateral triangle, which means all the sides are congruent. So once again, you can create an equation where you can solve for x. I'm not going to take the time to solve that, but if you like, we can pause the video and you can solve that on your own. So go ahead and do that. Okay, so now that you're done with that, let's continue on to the final slide here. Again, to summarize, the way we classify polygons are several different ways, and one of those ways is number of sides. We can tell whether it's convex or concave. We can indicate whether all the sides are congruent or all the angles are congruent. And so those are the various ways we could identify or describe polygons. That concludes this lesson.